Good afternoon, we are the team number 1 and we are here to present the physics PBL, and my teammates are Arnulfo, Alexis, Diego, Ruben, Bernabe and me, Ricardo Flores. Now here we are with the steps.
We have a case where a guy wonders himself what would happen if he mixed or moved a liquid with another one, in this case milk and coffee. He wonders about what will happen with this mixture and the temperature, and what will also happen if we put on some lead, and what will happen if we put on some ice or liquid water to cool itself.
Along this problem, we have some cases where the guy asks himself different scenarios. The first that this guy wonders is, how can the coffee get warmer? By mixing the milk 10 minutes after pouring, or stir immediately. Then he wonders if the drink cools off faster by just leaving it there with some ice. And what cools faster, if an ice cube or liquid water? And finally, how fast does the cooling happen when you pour a drink inside a cool device?
Well, we choose our question, that is how to keep a beverage at the same temperature. We choose this because the energy is not always conserved at 100%. There is always loss of heat due to the thermodynamic loss.
For solving this PBL, we have to understand one important concept, the specific heat. The specific heat is the amount of heat per unit mass required to increase the temperature by 1 degree Celsius. And the relationship between the heat, mass and temperature is expressed in the next formula. We have the heat equal to the specific heat per mass and change of temperature. Okay, so we want to keep the temperature of the liquid or the beverage at the same temperature. For this reason, we have to solve by a specific heat. Solving for a specific heat, in the divisor, we have the mass, and the mass is a constant that depends on the quantity of material is used for the glass, or in this case the thermal, and the delta T. This is the change of temperature. If we want to this quantity keep low, we need a high quantity there. And if this divisor is little, the quantity in the top or the dividend is high. For this reason, the value of specific heat needs to be too high for keeps the thermal for keeping the thermal at the same temperature. As explained before, the specific heat, to demonstrate the specific heat capacity, could absorb a lot of heat, because we have the beverage at any temperature. It's not important if it's cold or hot or hot, but the environment could apply heat on the system, or maybe absorbs of the system. But if the capacity of the heat is too high, the material could release or absorb a lot of heat, and it's important because the temperature of the liquid inside keeps equal.
As a conclusion, we found that the problem weren't so difficult, because this is the answer, and it's just a little algebraic trick, and we just need to get this value.
Well, as my partner here is explaining, we need to have a material to build the vessel with a high specific heat so that we can prove or obtain the best results to answer this question, as it would be that the coffee or the beverage doesn't get so cold in a lot of time because of the properties of the specific heat that will absorb the heat from the outside and won't let the heat from the inside get out.
So we have this formula, and if we put some values here, we get to the conclusion that it doesn't matter the mass or the other variables. If we have a high specific heat, there is the way that the temperature doesn't change too much. So it depends almost all in the characteristics of the material and in the vessel.
Well, for more information about the details of the formulas and the equations, the results, we have it all explained in the PBL document that we uploaded in Blackboard.
So this is a little explanation, and as my partner says, all the explanation with the things that we know and all the PBL steps are in the document. So this is the conclusion of the team, and then we have the application of these things.
The applications for this PBL that we consider are food and beverage conservation in different systems. This is because when you are in another place or another country with different heat, with different temperature, you can keep the heat or the cold in your fruits and liquids, or in this way, drinks. The other application is laboratory experiments, because when someone wants to keep the material or toxicity material in a certain temperature, they can do it in an easy way. They don't have to have an industrial machine. The last one is health applications. In the case of sports injuries, this is to keep hot or cold the part of any part of the body that the athletes needs. This is in the rehab that the athletes are doing in a period of time.
So thanks for watching. We hope you enjoyed this. I'll see you later.